So we're going to go ahead and start talking about factoring, and we're going to start by talking about finding the GCF. Now, for those of you who don't remember, GCF stands for the greatest common factor. That is the biggest value that will go into two things. So let's take a look at finding GCFs really quick. Factors. Let's remind ourselves what factors are. A factor are two or more values that multiply to make a third value. For example, if we were to look for the factors of 12, we would think about all the different combinations of numbers that would multiply to make 12. So 12 is equal to 1 times 12, 2 times 6, and 3 times 4. So those 6 values are all factors of 12. So whenever we're thinking about factors, we're just looking for any values that multiply to make our target. In this case, our target was 12, so the numbers 1, 2, 3, 4, 6, and 12 are all factors of 12. So let's look at some numbers and finding the greatest common factor of two values. In this case, we'll look at 12 and 16. So to start off, we're going to find the factors of 12. So factors of 12 from the previous problem we know are 1 and 12, 2 and 6, 3 and 4. If we look at 16, we can think about the different values that can be multiplied together to make 16. In this case, we know that 1 times 16 will equal 16. We also know that 2 times 8 will equal 16. And we know that 4 times 4 will equal 16 as well. In order to find the greatest common factor, we simply have to start by marking out which ones are in common. So we notice that both of these have 1 as a factor, they both have 2 as a factor, and they both have 4 as a factor. So our next step is simply to decide which of them is the greatest common factor. So if you look at these, our highest number that's shared between both 12 and 16 is the number 4. So the GCF of 12 and 16 is 4. And when we're looking at numbers, that's all we're really trying to figure out. What is the biggest number that divides into both of them evenly and leaves us with a whole number result? So 12 divided by 4 is 3, 16 divided by 4 is 4. Those are both whole numbers without any decimals or fractions attached, and that's what we're looking to find. So now let's look at something a little more difficult. The GCF of 8x squared y and 10x cubed y to the fourth. Now we need to figure out what all the parts of these two equations are. So we'll start with 8xy squared. The factors of 8 are 1 and 8, 2 and 4. Those are all the values for 8. When we think about the variable x and x squared, what we can do is we can write out how many x's are there. In this case, there are 2 x's, and there is 1 y. If we look over at 10x cubed y to the fourth, we'll break it down in the same way. So the factors of 10 are 1 and 10, 2 and 5. Those are the only values that multiply together to give us 10. We know that there are 1, 2, 3 x's, and there are 1, 2, 3, 4 y values. So now we need to figure out what do we have in common. Well, on the left-hand side, we have the number 2, and on the right-hand side, we also have the number 2. That's our greatest common factor numerically between 8 and 10. But now we need to compare our variables. So the question becomes just simply, how many of each variable do we have? On the left-hand side, we have 2 x's, and on the right-hand side, we also have 2 x's. On the left-hand side, we have 1 y, and over here we have 1 y. What we'll do next is we're going to simply look at all of these values and pull them together to figure out exactly what our GCF is. So we know our numerical GCF is the number 2, and we get that from 2 being the highest common factor between 8 and 10. We also know that we have 2 x's and we have 1 y. So when we simplify this, we get 2x squared y. Let's find another one. So here we have 36a squared b squared c and 12a b cubed c squared. So factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. For 12, we have 1 and 12, 2 and 6, 3 and 4. We can immediately see right off the bat that our greatest common numerical factor is 12. As we start looking at our variables, we can simply think about how many of each do we have. In this case, we have A, and over here we just have 1A. So we know that our GCF will have only 1A. We have B, and we have B, and B. In this case, the 2 B's on the left-hand side will be our greatest common factor. And finally, we have 1 C on the left-hand side and 2 C's on the right. So once again, our single letter C will be our greatest common factor value, because you can't pull out 2 C's from a value that only has 1. So when we put it all together for our GCF, we get 12A B squared C. And once again, that's stating that our common numerical factor is 12. We have 1A in common, we have 2 B's in common, and just 1 C in common. So 12A B squared C. Let's look at one last example about how we use GCFs to factor out of a problem. In this case, we'll look at our original problem. Instead of it simply being finding the GCF of 8x squared y and 10x cubed y to the fourth, we're going to turn them into an expression of 8x squared y plus 10x cubed y to the fourth. And your goal is to factor out the GCF. In this case, what we're doing is we're taking this problem and we're going to turn it into a new problem, where we have our GCF on the outside and 2 new values inside the parentheses, that when you were to distribute your GCF to everything inside, you would get our original equation back. Remember, what we're really doing is multiplication in reverse. That's what factoring really is. So, we know from our earlier problem that our GCF is 2x squared y. And now we need to figure out what goes inside. So to do this, what we're actually going to do is divide our initial value of 8x squared y by 2x squared y. And there's some easy ways to do this. Really, all we're thinking about is what value can we put in here, this empty spot, so that when we multiply 2x squared y by that value, we'll get back 8x squared y. So we have a 2 on the outside, and we need to get to 8. So what do you multiply 2 by to get to 8? In this case, it's going to be 4, because 2 times 4 is 8. If we look at our x squareds, we see that we have an x squared on the outside. So x squared times what equals x squared? In this case, it would be 1. So x squared times 1 gives you x squared. So we don't actually have to write anything else here in this spot. It can just stay blank. And we'll do the same thing while looking at y. We have a y on the outside here, and we need to get a single y on the inside. So y again times 1 will simply equal y. So again, we don't have to actually add anything to this 4. But now we need to really think about what do we need to put over here. So 10 divided by 2 is what? Gives us a 5. It's because 2 times 5 will give us 10. We have an x cubed that we need to reach, so x cubed divided by x squared gives you x, because x squared times x will give you x cubed. And finally we have y to the 4th. Y to the 4th divided by y gives you y to the 3rd, because y times y to the 3rd will give you y to the 4th. Now we need to figure out what symbol goes in between them. In this case, we know that our 10x cubed y needs to be positive, so we're going to leave a positive value in here. So when we factor out 2x squared y from the 8x squared y plus 10x cubed y to the 4th, we get a final value of 2x squared y, parentheses, 4 plus 5xy cubed, end parentheses. That's all about what it is factoring out or dividing out that greatest common factor. So to finish up, we're going to do some practice. Follow this link and complete all the practice problems in your notebook. It also includes some backup multiplication practice on multiplying polynomials and binomials. So goo.gl/N9 capital X OP capital U.